Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2012 Calculus BC free response question number 6. This is a non-calculator free response question that reads, the function g has derivatives of all orders, and the Maclaurin series for g is the summation from n equals 0 to infinity of that expression. And there's only 3 questions. It says, part A begins with, using the ratio test, determine the interval of convergence for the Maclaurin series of G. So let's talk about the interval of convergence. Well, remember, interval of convergence is the interval under which our summation, which is this expression right here, this expression, when are we most aligned with the function that we were meant to represent? Well, from here, in order to initiate a interval of convergence, it's going to start off with the limit as n goes to infinity of the absolute value of x to the 2 and then n plus 1 over 2n plus 1 plus 3. And that's going to be multiplied by the reciprocal of the original expression. So it's going to be 2n plus 3 over x to the 2n plus 1. Now, the absolute value, it's important to note that the absolute value is what gets rid of the alternation. So if you're wondering why I did not include this negative 1 to the n, it's because when we do the ratio test for absolute convergence, we actually remove the alternator, which makes all of the terms positive. We'll have the limit as n goes to infinity of x to the 2n plus 3 over 2n plus 5 times 2n plus 3 over x to the 2n plus 1. Now from here, some things are going to be able to go away here. It looks like I'm going to have the x to the 2n's cancel each other out decently. And that might be it. I mean, there might be some other like miscellaneous cancellation that happens, but that's the major thing that's really going to happen. Now if you notice, there's an x to the third right here because these two terms are being added, which means I really have an x to the third with an x to the first on bottom. So what that gives me is it gives me x squared at the top when all is said and done. The n terms can't really do anything, so it's going to be multiplied by a 2n plus 3 over a 2n plus 5, which is actually a pretty good position to be in. Because as n goes to infinity, this portion of the expression right here will go to 1, leaving me only with the absolute value of x squared. Now in the ratio test for absolute convergence, the result of the limit is then compared to the number 1. Remember, it's treated exactly like a geometric series. We're going to compare the result of the limit to 1 to find out the interval of convergence of the actual summation. So from here, that means that my radius will be 1. And my interval will be from negative 1 to 1 because this guy here is centered at 0. And then we'll go back 1 and forward 1 because of the absolute value, the distance from the x squared, or the distance from the 0 being 1. And so from here, all we have to determine is what types of brackets to put around the negative 1 and the 1. So how do we do that? Well, I'm going to go ahead and test out what's happening with the series exactly at those points. So at x equals negative 1, it will be the summation from n equals 0 to infinity of negative 1 to the n times, looks like negative 1 in this case, to the 2n plus 1 over 2n plus 3. Well, because the bases are the same right here, what I can do is I can make this summation from n equals 0 to infinity of negative 1 to the, looks like 3n plus 1. Now, if you allow n to equal 1, 0, 1, 2, 3, ... what you'll find is that this thing actually alternates between positive and negative values. This guy is going to stay exactly as he is, so he'll stay 2n plus 3, and because this series alternates, we are able to employ the alternating series test on this thing. So we can say that a sub n is alternating, a sub n is decreasing in absolute value, and then the limit as n goes to infinity of a sub n equals 0. So we can then say that we converge the sum from n equals 0 to infinity of negative 1 to the 3n plus 1 over 2n plus 3 converges by the alternating series test. And what that allows us is it allows us to put a hard bracket on the negative 1. So we got to do another one of these. Oh, darn it, I'm almost out of space. Okay, let me just clean up the board a little bit here. All right, I'll go and take a look at it in a different color here. So at x equals 1. So from here, that will look like the sum from n equals 0 to infinity of, looks like, negative 1 to the n, and then 1 to the 2n plus 1 over 2n plus 3. Well, this guy is just going to become 1, so it doesn't really matter what exponent he's being raised to. So it looks like I've got negative 1 to the n over 2n plus 3. So for the exact same reason, it looks like we're going to be converging on either side. So again, it looks like the alternating series test is going to play a role in the positive 1 being convergent as well. So a sub n is decreasing in absolute value, a sub n is alternating, and the limit as n goes to infinity of a sub n is 0. So once again, the sum from n equals 0 to infinity of negative 1 to the n over 2n plus 3 converges by alternating series test. And what this allows me to do is it allows me to put a hard bracket around that 1, and that wraps up part A. Let me go and clean up the board and we'll get ready for part B. Alright, part B. While wordy, it's actually not terribly difficult. It says the Maclaurin series for G evaluated at x equals 1/2 is an alternating series whose terms decrease in absolute value to 0. The approximation for G of 1/2 using the first two non-zero terms of this series is 17 over 120. Show that this approximation differs from G of 1/2 by less than 1 over 200, excuse me. Well, this one here, this is your first dose into an FRQ style question of alternating series error bound. And so while wordy, it's actually pretty simple to do. So what they're saying is that the approximation for G of 1/2, right? And so what we're going to do is we are going to actually evaluate this Maclaurin series at x equals 1/2. So what does that look like? Well, G of 1/2, and I'll only do the first few terms here. Instead of x over 3, it'll become 1/2 over 3. And instead of x cubed over 5, it'll become 1/2 cubed over 5. And then plus 1/2 to the 5th over 7. Now, they're telling me that the approximation using the first two non-zero terms is 17 over 120. So what does that mean? That means that these two guys added together become 17 over 120. That's what they're telling us. They told us that, we know that. And they want us to show that this approximation, in other words, this number, differs from G of 1/2 by less than 1 over 200. Well, remember, in alternating series error bound, if we're summing up the first two terms, that means that term 3 is the error bound. And so if our error bound is less than 1 over 200, that means that our summation will be less than 1 over 200, right? So let's write that down. If the error bound is less than 1 over 200, right? This is the desired error. If the error bound is less than 1 over 200, then the actual error will be less than 1 over 200. Okay, so let's find out what this error bound term's value actually is. Well, that's going to be 1/2 to the 5th over 7. Well, that's going to be 1 over 32 over 7, which is 1 over 32 times 7. Now if you actually take the time to calculate this, this ends up becoming 1 over 224, which actually is less than 1 over 200. So the point of this problem was to show that your third term, which is the term following the first two terms, was less than 1 over 200, and therefore, because your error bound is less than 1 over 200, your actual sum would be less than 1 over 200. So I would just identify him as error bound, term number 3. And that should wrap it up for part B. So yeah, while wordy, it's a little bit easy to do, I think, as long as you kind of understand what error bound is trying to have you determine. Okay, let's take a look at part C. We're almost out of here. Alright, in part C, they're asking us to find the first Alright, in part C, they're asking us to write the first 3 non-zero terms and the general term for the Maclaurin series of g prime of x. So, pretty simple. We'll just derive the individual pieces. If you look back up the original series, you can then say that g prime of x would then be equal to 1/3 minus 3/5 x squared plus 5/7 x to the 4th minus ... Now, if you want to write the general term for this thing, the general term, because if you notice, if you look at the series at the top, it's defined at n equals 0. So if you want to stick as close to the letter of the law as possible, what you want to do is you want to say, okay, let's just let this guy start at 0, this guy start at 1, this guy start at 2. And at this point, you kind of have to feel your way through it. What you can do is you can, of course, it's going to alternate. It's going to be -1 to the n. If n began at 0, this would make this -1 positive, which makes sense. If you look at the top terms, they're moving up by a slope of 2. So you know your top terms, and your bottom terms for that matter, are linear. So you can call them 2n over 2n, and now you just have to adjust and make sure that they work according to what you have. So 2n looks like if I add 1 to the top, it should make sense, because if n equals 0, I get 0 here, which makes them 1. If n equals 1, then I get 3, and then 5, and that should make a certain degree of sense right there. This guy should be added by 3, because that's how you get the first term when n equals 0. If n equals 1, do I in fact get a 5? I do. If n equals 2, do I in fact get a 7? I also do. And then x would then get raised to, looks like the 2n. Looks like because the slope is going up by 4, or by 2 rather, we get 2 and then 4. So that should make a certain degree of sense right there. And I would just say with n starting at 0. Now if you wanted to start from 1, that's also possible. The general term for this would then be an alternator of -1 to the n plus or minus 1, it's up to you. To get the first term, so if again I say n equals 1, n equals 2, n equals 3, you would just finagle your pieces to go accordingly. So again, it would be 2n on top and bottom, just because of where we start doesn't mean that we're changing the slope here. So I would say 2n looks like -1 would be how I begin if I began at n equals 1. And then looks like I would go with +1 on bottom, and then x to the 2n minus 2 would be my piece right there. So from here, that would be with n starting at 1. So it just depends on how you want to begin the general term and where you want to begin it with. And that should wrap up your final free response question from the 2012 AP exam. As always, thank you for hanging out with me and spending time going over these free response questions. If you have any questions or comments, go ahead and leave them in the comments section and we will address them accordingly. And hope you are staying safe and staying indoors, and we will see you in the next video.